Hello everyone, welcome back to HMAT1033. Let's continue with radical expression we had last time. So in this video I will be discussing how to add, subtract, multiply and dividing radical expression. So let's get started. Okay. Radical, sorry, it's not working some way somehow. Alright. Radical simplification. Okay. So on the first part of the video, I want to discuss how to adding and subtracting radical expression. Okay. In order to add or subtract radical expression, there are two conditions. Your expression must satisfy two conditions. First, the radical, the index, must be the same, which is the same radical. Okay, same radical. Second thing is it must be the same radicand. Last time I already talked about radical and radicand. Right? Radical is the index, you know, the type of the radical, and the radicand is whatever inside the radical. Okay, so the same radical, it means the same index. Index n, which means that if it is square root, the radical you add or you subtract it by must be also square root. If it is third root, the radical you added to or subtracted by it also must be a third root, and so on and so on. Okay. I'm sorry. So it must satisfy two conditions in order to add or subtract. If one of them is not satisfied, then you cannot add or subtract. Then after you see that the radical and the radicand are the same, you can add or subtract it in the same way you combine like term. 2x plus 3x, remember that? 2x plus 3x equal 5x. So the same, the method you add or subtract will be the same way as you combining 2x plus 3x, something like that. Okay, let's start with the first example here. Sorry guys, I still have a very bad allergy. Alright, how about this one? I have 4 radical 5 minus 2 radical 5. Alright, so let's check if it is satisfy these two conditions or not. First of all, it must be the same radicand, you know, inside is 5 and 5, right? It is same. Is that the same radical? Yep, so this is square root. This is square root. It's the same type of radical. So right now you can subtract it. 4 minus 2 give you 3 radical 5. You see that? It's kind of the same as you add or subtract when you add or combine like term. You know, add or subtract like term, you know, you just keep the denomination. The radical 5 over here is nothing but denomination, and you just add or subtract the coefficient together. Okay, so that's this subtraction, and you can do the same for addition. For example, I have over here, I have 5 keep root of y plus 4 keep root of y. And you see that, is it a radical the same? Yeah, it's y and y. Is that radical the same time? Yep, it's third root. So you just go ahead and add them up, which is give you 9 cube root of what? Of y. Okay. Alright. Now What if the radicand and what if the radicand is different? For example, in this case, in the example number 2 here, how about I have like 7 fourth root of x, and I want to add to 2 fourth root of y. In this case, you cannot do it. So you cannot add 7 to y. Okay, you cannot do anything. That's all. You just can, because the radicand, you see, that does not satisfy the condition here. The radicand is different. Even though the radical is the same, 4 and 4, but the radicand different, so you can do it. Can do it. All right. In the first example here, you see that it's so simple, because you don't have to simplify anything. You know, in the second example I give you, because last time in class when we talked about how to simplify radical, remember, radical expression, the purpose of simplifying is it helps you to add or subtract. Later on, it's going to help you to solve radical equation. Now, let's take a look at this one right here. How about if I want to add or subtract 3 radical expressions together? How about something like it? I have fourth root of 3xy, okay, plus 5 times fourth root of 3xy. Let's see, this is the radical, they're the same. The radical so far are the same too. More minus 4 times fourth root of 3xy. 3xy. Let me rewrite this a little bit. This make it a little bit bigger. So fourth root of 3xy. All right. So 3xy is they're radicand, and see that the radical at the same time. So we just go ahead apply the PEMDAS rule. We're gonna combine like term from left to right, right? So in this case, we're gonna go from left to right, so which is this invisible one right here, give you 6 fourth root of 3xy minus sorry, minus 4 fourth root of 3xy, which is give you 6 minus 4 give you 2 fourth root of 3xy. There you go. So you're gonna do the same for as many as radical expression you want. You can add or subtract them together. Of course, you have to apply the PEMDAS rule, and if it addition is subtraction, you just need to go from left to right. Alright. Now in the third example, what if I have something like this? I have square root, okay, of 20 plus 3 square root of 5. Maybe some of you look at this one and you see that the radical is the same, because it's the same type of root, square root. But the thing is that the radical is not the same. So probably you guys, some of you just jump into the conclusion and say that we cannot do it. The same thing as example number 2 I have here. But you have to be careful, because in the example number 2, everything already been everything is simplified already. In example number 3, the square root of 20 is not simplified. So maybe after we simplify, we can have it the same. You know, we're not sure. So in order to add or subtract radical expression, first step you have to do is you have to simplify everything out. All right. So let's simplify this. And last time I already showed you how to simplify this. So you can split them into something square, or you can split them into something you can take a square root. For example, square root of 20 is square root of 4 times 5. And over here, 3 square root of 5. And square root of 4 is 2. So you can take them out. Square root of 5, you cannot do it. And now you still have it. And now, what do you see? So after I simplified it, simplify square root of 20 is 2 square root of 5. See the radical the same. And now we can add it. So we do 5 square root of 5. Okay. So what we learn from this example? What we learn is that sometimes the question doesn't give you the same radical or radicand. You have to simplify some way somehow. After you simplify and it's still not the same, then you can jump to the final conclusion that you can do it. But after you simplify and you see it the same, here you go. Now you can add it. Okay. For example, in example number 4, I have here. I have cube root of 24 minus cube root of 375. Alright. So how we're gonna split up 24 into something so that we can take a cube root? I mean, that one seems to be very easy because I know it's 24 is 8 times 3, but the problem is this one right here. It's this pretty big number. So we gotta do the prime factor tree here. You know, the prime factor tree is gonna help you to deal with bigger numbers. So 375, and you split it up into let's see, into 3. So give you 155, right? Or 200? No, it's give you 255, right? Or I'm sorry, you know, sometimes I cannot do the division here, so I'm pretty bad at you know, mental math and related to division. So I just want to use calculator here to do it. It's faster and it's more accurate. 125. Can't believe it. Can't believe it. Sometimes I couldn't do it, you know. Alright, so 125. And you keep factoring, which is you find 25, and over here and find 5. So let me circle all the prime 1. Okay, this is all the prime 1. So this is the third root. I can write something raised to the third power, so it become 5 to the third power times 3. Okay. Now I'm going to apply one of the property we had last time. Remember this one, and root of x to the n is give you x. We already talked about this. Okay, I'm going to circle them to remind you. Box them. Okay. Now I'm going to apply. Now I'm going to apply this formula here for cube root of 5 to the third power is 5. It's cube root of 8, everybody knows it's 2. Cube root of 3 inside. This gives you 5 cube root of 3. So you see that after I simplify, I see that they are same radicand. So give you negative 3 cube root of 3. That's the final answer. Okay. So don't panic if you see something. If you see different radical and radicand, you just need to simplify it. Of course, sometimes it's easier for you to simplify. Sometimes it's a pretty hard one. Alright, now let's do more example with variable. Example number 5. How about I have something like this. I have 9. 50 m squared minus 6 48 m squared. Okay, now the radical are the same, but the radical is different, so we have to simplify it. So we know that I can split it up over here, right? Because 50 is nothing but 25 times 2. 25 times 2 m squared. And 48, I can do 16 times 3 m squared. And I'm going to apply the yellow box property one more time here. For the m squared, square root of m squared give you m, square root 25 give you 5. So 5 times 9 outside, 45, right? m outside, right? Square root 2 minus square root 16 is 4. 4 times 6 is 24, and square root of 3 inside. Alright, so what we learned from here. So after I simplify, I see that the radical the same type, but the thing is it has different radical. One is 2, one is 3. So we can combine over here. We can do it. Okay, because we're stuck out here because it does not satisfy one of the conditions we have. We're supposed to have. Okay. Now let's do another one. How about this one here? Example number 6. What if I have third root, okay, of 135 x to the 7, okay, minus third root of 40 x to the 7, okay. Alright, so in this problem, this example, there's two different approaches. You can split it up by using you can split it up, then apply the yellow box right here, property right here. So we're gonna have something with the third degree, third power, and you can take because the over here the cube root, so we can have something with the power, or you can use this formula, this one. You can use this. If you have m root of x to the n, it just give you x to the n over n. I think I mentioned this formula last time too. And we can use this one. Okay, but in order to use this one, you see that m must go into n evenly, because if m is not going to n evenly, we will have a rational exponent. We have a decimal exponent over here, and that's what we don't want. All right, but now 135, we can go ahead and factor them out. So it will be 5, 27, right? 27 is 3, 9, right? And 9 is 3, 3. So we have 3, 3, 3, 5. And how about for 40? So 40 will be 2, 20. 20 will be 2, 10. 10 will be 2, 5. So you have 2, 2, 2, 5. So this I can write it as cube root 3 to the third power times 5. Now x to the 7, I can split it into something so that 3 go into that. So I can split them as x to the 6, right? Because 3 go into 6 times x. Because x to the 6 times x is x to the 7. And over here, I can write it as 2 to the third power times 5 again. X to the 7 will be x to the 6 times x. So cube root of 3 to the third power, we're going to apply the yellow box here, which is give you 3. Cube root of 5, you cannot do anything. Cube root of x to the 6, we're going to apply this formula here, which is give you x squared. So what I have left is cube root of 5x. The same thing over here. I have 2x squared, and I have cube root of 5x inside. And now we see that we have the same. We have the same radical. I can add up. I can subtract up. So 3x squared minus 2x squared give you x squared cube root of 5x. Okay. Good. So that's how you add and subtract radical expression. Now on the second part of the lecture, I would like to discuss how to multiply and dividing a radical expression. Okay, let's see how we're gonna do this. Well, in order to do this, the good thing about multiplying and dividing is this: you don't have it doesn't have to be the same radical. It just need to be the same radical. So the requirement here is same radical. Okay, that's a requirement, and we're gonna apply this formula. Okay, so n root of a times n root of b, so give you n root of a times b. The second formula is n root of a divided by n root of b, which is give you n root of a over b. We already learned this formula last time. Okay, so we're going to apply these two formula here, and we're going to check if it's the same radical or not. Okay, because you see that even a and b is different, the radical is different, but the radical must be the same in order for it to be multiplied or divided. Okay, so let's see how we do it. Let's start with our first example. Now let's start with something simple first. Okay, about something like this. Example number 1. I have two radical expressions: 6 square root of 2 times 3 square root of 10. Okay. Alright, so I'm gonna just need to multiply the coefficient, which is 6 times 3 is 18. Then I'm gonna apply this property because the radical the same. So I may just need to multiply the radical together. So I just combine it under one radical. Alright, so see that? So which is u18 square root of 20. But maybe some of you are gonna think that we're gonna stop right over here. But remember, whatever we do, we have to simplify it, because radical expression or any type of mathematical expression, at the end it must be the simplest form. So I can split it up. 18 is 4 times 5, and now you see the square root of 4 is 2. 2 times 18, which is the 36 square root of 5. Okay. Alright, example number 2. That's pretty simple, right? Now, what if I have something like this? Let's square root again. Okay. Okay. Now, how about this one over here? This one with variable. Let's see how we're gonna deal with variable here. So we have 10 square root of 6p to the third time. Actually, every time you multiply radical expression, there are two different strategies. You can apply the formula right away, combine them under one radical, or sometimes you can simplify each of the radical expression first. But in my opinion, I think we should go ahead and apply right away, then simplify later. I think that is better for you. So I'm going to multiply this because this is coefficient, so 10 times 4 is 40. So I'm going to combine it under one radical, which is give you 6 times 3 is 18, right? and p to the third time p, which is p to the 4. See, I just combine it. And when you combine it, just go ahead and multiply the radical together. Right? And now 18, I can split it up into something so that we can take square root, so 92. And p to the 4, remember that we can apply this formula. Let's see. I think did I apply the correct formula here? Yeah. Okay. I'm sorry. I thought I got something wrong. Okay. So p to the 4, I can do. I can apply this formula, right? So I'm gonna just keep p to the 4 right now. So square root of 9 is 3. 3 times 4 is 3 times 40 is 120. The square root of p to the 4, apply this formula, give you p squared. And square root of 2 will be inside. You cannot do anything with that. There you go. And that's it. We can we're gonna leave it like that because it's already simplified. Okay. Now let's do another example. Something. Let's do something harder. Example number 3. Now I'm gonna do this one with fourth root. So we have 2 fourth root of 20 y squared times 3 times fourth root. You see that the radical is the same, 28 y to the third. Alright, so I just apply the formula. So just go ahead and multiply the coefficient. So 2 times 3 gives you 6. And you combine it under radical 4. So which is, oh, that's a pretty big number over here, right? That's a pretty big number. Okay. So that's okay. We can just go ahead and multiply them up because we stick to one strategy only. Usually, I will be, if I do it, I'm very flexible. I try to simplify each of them. But I mean, because when I show you, I said just stick to one strategy, you know, one tactic. So we have 5, 6. You multiply them up, 20 and 28. And y2 times y third is y to the 5th. Okay. Now we're gonna try to do prime factor tree for this, so that we can rewrite something with fourth exponent because this is the fourth radical. So 5, 6t. You simplify it. You try to divide by 2, give you 280. You divide by 2 again, give you 140. Divide by 2 again, give you 70. Divide by 2, give you 35. And you see that 2, 2, 2, 2. I mean, you can go ahead and split it up again, but I don't see the point because if you split up with you 7 and 5, so this is 2 to the 4 power already. So right over here. So I can write it as 6 fourth root of 2 to the 4 times 35. Now y to the 5th power, I can write it y to the 4 times y, right? So because this is the fourth root, so I want to write something to the 4th power so that I can take them out. So this is give you 2, I can take them out right now. Y, I can take them out. So what I have left is just 35y. And the final answer will be 6 times 2 will be 12y. Fourth root of 35y. Okay. Good. And every time we talk about multiplication, we talk about a distributive property, right? Now in the example number 4 here, I'm going to give you something with parentheses. And we have to apply distributive property. Okay, how about something like this? I have 3 minus 2 square root of 7 times 4 minus 2 square root of 7. So if I apply distributive property, if you guys forgot, we just need to draw the arrow. Okay, let's draw the arrow. Okay, so we're gonna do something like this, right? And we're gonna do something like this, and it's like that, and like this, right? Okay. Alright, so 3 times 4 will be 12. 3 times negative, 3 times, but sure you have to multiply the side too. You negative 6 square root of 7. Negative 2 times 4 will be negative 8 square root of 7. Negative 2 times negative 2, which is give you 4. Square root of 7 times square root of 7. Okay, which is square root of 49, right? Square root of 49 is 7. Okay. Now we just need to combine like terms. Will be 12. Now negative 14 square root of 7 plus 28, and you combine with this one. 28 plus 12 will be 40. Right? Minus 14 square root of 7, and that's it. Okay. It's pretty easy when you apply distributive property. Good. Yeah, and you're gonna do the same thing for third root and fifth root and for all the root. Okay. You just do the same way. Now on the next part, of this second part, I want to talk about division. So I don't know. Last time I split it up into 2 parts. I know I just give you the. Let me see. I think I just give you the example without split it up into 2 parts, right? Yeah, I did not split up. So I think I'm gonna just go ahead and continue with example number 5 here. And in example number 5, we're gonna do division. Okay. I'm gonna have something like this. I have square root of. I think I'm gonna change the color. Let's change the color for division. I have so many different colors over here. We can pick one of them. How about this one? Is this one good or not? Oops, this is not good. Nah, it's not nice, right? Well, I don't have any other color. I have red. I mean, example number 5. Okay. Let's see what we're dealing with. Okay. I'm gonna decrease it. Okay. Example number 5. Okay. Red color is not nice, right? I mean, it's kind of dark. It's too dark. I mean, it's not good. So I think when I just go back, how about blue right here? You know, we just have some fun with all the color, you know. Example number 5. Let's try it. Oh, that's blue is okay, huh? Blue is okay. Let's try blue. Okay, I have square root of 72 x to the 3rd power over square root of divided by divided by 162 x. Now I'm going to apply the formula so I can go ahead and combine them together. So I have 72 x to the 3rd over 162x, and now I can simplify this. Let's see. I simplify the fraction here. So 162 divided by 9 will give you 18. 72 divided by 9 give you 8. Okay, so both of them divided by 9, so this is give you 8, give you 18. And x to the third over x, we can apply the exponential property, so subtract the exponent, which is give you x squared. In 8 and 18, I can simplify more, which is divide and start the bottom by 2, which is give you 4 over 9 x squared. And now square root of 4 over 9, we know that for square root of 4 over 9, this is a perfect square for 9, so we give you 2 over 3. And square root of x squared give you x. There you go. Ooh, blue, I don't know, blue is good, and and it's kind of weird blue right here. I don't know. Just, I think it's not really that bad, but it's kind of dark, right? Yeah, I mean, I think we just need to change another color. And let's try this one right here. What color is this? Oh my god, I cannot see anything here. Oh no, this is not the paint. This is like, it's a paint. So I'm gonna have to erase this. Yeah, it's not a paint, I'm sorry. So yeah, I think we gotta go back to this blue again. So let's play a little bit with more blue, even though it's kind of dark. Alright. Example number 6. How about if we can do something with variable? How about I have a square root of 147 ab to the 8, and I want to divide it by square root 3 a to the third b4. Okay, then I can combine them. Yeah, I think I have to change the color next time. So 147 divided by 3. Okay, first we'll go ahead and combine them. 147 ab to the 8, and I want to put a 3b4. So 147 divided by 3, let's see it happening. Give you 49. It's pretty nice number. Okay, then a over a to the third, which is give you a square, right, at the bottom. b8, b4 give you b4. So I don't have to review this because I assume that you guys already learned this. Okay, so it is square root 49 7 square root of b to the 4 and give you b squared. We remember the property I put in yellow up there, and this is give you a, and that's your final answer. I don't think I can stand the blue one. Let me see here. Alright, example number 7. This is a terrible color. Ooh, I think I'm gonna have to change down. Let's change to white. Maybe we have to change to yeah, I gotta change to, how about this one? No, we don't want to use this. How about this? Let's see. How about this green right here? Maybe this one, but this one we already used it, right? How about this one? Okay, let's see. Example. Okay, so maybe that one is better, huh? Now let's do with third root. Remember that for the third root we can take a negative number, because third root is even root, is odd root. So we can take the root of negative number. But for the even root you cannot do it. So this is third root of 2 and negative 2 and to the 4. Alright, go ahead and combine them first. So let's give you the third root. Negative 250 m and negative 2 over 2 m negative 2 and negative n to the 4. 250 divided by 2, we have to simplify that one first. Give you 125 negative 125. We know that m minus so m to the third on the top, and at the bottom we have n to the 6th power. And negative 125, I can split it up into negative 25 and 5, right? M to the third, I can split them to m square and m. And n to the 6 is even. So the radical 2 over here can go into 6, so we can apply the formula. So which is cube root. Oh, this is cube root, I'm sorry. Okay, so we cannot split it up right here, I'm sorry. So it is m to the third, because this cube root is go straight into m to the third right here. So the cube root, we're not going to go ahead and split it up this one either, because I thought it's square root. So we don't, oh, I'm sorry, we don't have to do this. Alright, so right now cube root of negative 125 will be negative 5. Cube root of m to the third will be m, and cube root of n to the 6, 3 go to 6 will be n squared. There you go. Oh, and it's this yellow colors is nice, right? I mean, I think I like it. Okay. So I'm not gonna give you something with you know, a fifth root or seventh root. Actually, the concept will be the same thing. You just combine them, and if it is the fourth root, you just need to convert it to something with raised to the 4, so that you can take them out. You know, but every concept will be the same. There's nothing hard right over here. Okay. All right. Now, that's the second part of the lecture. Okay. On the third part, I will be talking about. This is very important concept too. I will be talking about radical rationalization. Rationalization concept is like a simplification concept. The thing is that you're not allowed to have, after you simplify your radical, right? And for example, your radical is in fractional form, and at the end you have a radical under denominator, which is not beautiful. I mean, it's not wrong, but if you have the radical under the denominator, it's not nice. So it's still considered unsimplified if you see your radical under denominator. So the thing is that if you see something radical with under denominator, you have to do one more step, which is rationalization. So a rationalization process is nothing but getting rid of radical under denominator. Okay, it's getting rid of radical under denominator. It is a process of getting rid of radical in denominator. Okay, so every time you do radical simplification, okay, and if you see your radical in the denominator, it's not completed yet. Okay, you have to do one more step, which is rationalization. Okay, now let's take a look at the first example over here. And again, we're gonna start with something very simple first. Okay. Okay. All right. So it takes time for me to pick up the color because I want to have more color, but I couldn't find any more, so I think I'm gonna go back to the white one. Let me see, maybe we can use yellow again. I think I like that type of yellow, huh? Alright, that's pretty good right here. Alright, example number 1. Okay, so I'm gonna have something again. I have something simple, and how about this one right here? Alright, I have 4 over square root of 3, and I want to rationalize it. Now again, it depends on the type of radical. Over here, this is square root. This is second radical. So in order to get rid of the denominator here, in order to get rid of the radical in the denominator here, you need to multiply something so that you can remove the radical. Again, remember this formula. We have n root of x to the n give you x. So you see that if the radical and the exponent, if the radical, the index and exponent are the same, you can remove the radical. So it means that if I multiply something so that the index and the exponent are the same, I can remove the radical. In this case, I'm going to multiply. I'm going to multiply the top and the bottom by radical 3. Why I have to do so? Because when I multiply by radical 3, okay, I have radical 3 times radical 3, which is radical 3 squared. Square root of 3 squared. You see that? Square root of 3 squared is 3. So what I have left is 3. See that? Now we don't have any radical in the denominator. It's already been moved to the top. Okay. Example 2. Now later I'm going to give you something interesting. Because right now what you see is square root. It's the second radical. So if you see second radical, you just need to multiply the top and the bottom by the bottom. So you see this again over here. I'm going to multiply the top and the bottom by the bottom. In this case is square root of 6x. Alright, so you're going to have 3 square root of 6x. At the bottom here we're going to have square root of 6x squared, right? Because square root of 6x times square root of 6x gives you square root of 6x squared, and square root of 6x squared, you can apply this, give you 6x. And on the top you have 3 square root of 6x, and 3 cancel with number 6 over here, which is square root of 6x over x. There you go. Okay, good. That is square root. All the problem I give you so far is square root. But what if I have cube root? Okay, what if I have cube root? What if I have this? 1 over cube root of 6. Remember, in order to remove the radical, this is the index. So inside must be the third power. Must be the exponent, the third exponent. But we already have 1. So you just need to multiply. You don't need to multiply the top and the bottom by the bottom anymore. But you multiply the top and the bottom by third root of 6 squared. Because you multiply the top and the bottom by third root of 6 squared, you have square times 6 will give you 6 to the third. And if it gives you 6 to the third, you can remove the radical. So this is 6 to the third. You see that now you can remove the radical. 6 squared 36 over 6. Okay, see that? So it depends on the index. But for the square root, you just need to multiply the top and the bottom by itself. But for the other one, you have to be careful. For example, this case right here. Now, for example, this case, you have 2 over 4th root of ax. So I'm going to multiply the top and the bottom. I'm going to rationalize it by multiply the top and the bottom by the 4th root of ax to the 3rd. Because we already have ax. So we have 3 more times. Okay, so that it make it to the 4 times. Okay, to the 3rd. So this will give you 2 4th root of ax to the 3rd over, alright, so you 4th root of ax to the 4th, you know, because this is 1 time, you need 3 more times, which is give you 4 times, and 4 and 4 we can cancel them out, so you have 2 times 4th root of ax to the 3rd over ax. Okay, like last time in the first 2 examples, you're gonna stop right over here because you cannot do anything. Oh, square root of 36, probably you can do something. I forgot to simplify over here because 36 is 2 and yeah, you gotta simplify 36. So it'll be can we? Let's do a prime factor tree over here. So 36 is 2 is 18, right? 18 is 2 and 9. No, we cannot do it. 9 is 3 and 3. So there's nothing we can write it as the 3rd power. So you cannot simplify this. How about this? You have to be careful because sometimes you have to simplify more. So how about this? A to the 3rd power. A to the 3rd power is actually 8 times 8 times 8, right? And 8 is 2 times 2 times 2. So it's 2 times 2 times 2. 2 times 2 times 2. And we want to, in order to simplify, we want to write it as something raised to the 4. Okay, I want to write something raised to the 4. Okay, so look like, let's see how many pair I can get for so that you can raise to the 4. So look what I have. Oh, here you go. I have 1 pair of something raised to the 4. I have another pair of something raised to the 4, right? So right now I can write it as 2 4th root of 2 to the 4, right? Times 2 to the 4, right? Oh, what you have left is number 2 over here, and x to the 3rd power here. Okay, over ax. Okay. Now 2 divided by 8 is give you give you 2. Give you 4 at the bottom, and the top you have this is, you can take it out 2, so give you 4, right? And you have 4th root of 2x to the 3rd over 4x, right? Because 2 divided by 8 is 4. Now you cancel the 4, so you have 4th root of 2 to the 2 times x to the 3rd power over x. That will be your final answer. So it depends on the radical. So you see which one you should multiply it by. Let me see. I can give you something a little bit more challenging, something with the 5th radical. Let's see. Let's see. Something fun, right? You wanna have something fun. All right. How about something like this? It's a very interesting problem right here. I think I'm gonna change the page. I think I need more space here. So what example already? So this is should be number 5, huh? Okay, example number 5. Now what if I have this? I have rationalize this 12x over fifth root. So this is fifth root, so we're going to multiply by we need to multiply another fifth root, and the inside must be something raised to the 4 power, right? Because it's 4 power, the 4 power 4 times, another time we use 5 times. So I'm going to multiply by 12 fifth root of 9x to the 4 raised to the 4, right? There you go. Over, and you multiply over here 9x to the 4, and you multiply over here the fifth root of 9x to the 4 raised to the 4. See that? Which is 4 1 time 5 times, so give you 12 fifth root of 9x to the 4 raised to the 4. That's a pretty big number. Alright, so which is fifth root of 9x to the 4 to the fifth power, right? There you go. Fifth power, the index is the same. I can remove the radical, so give you 12 fifth root of 9x to the 4. We have to simplify right over here. Right over here. See that? Right over here later. And this is, I remove the radical, so what I have left is just 9x to the 4. But before I simplify this, I think we can simplify 12 and 9 first, which is give you 4 and 3, right? 4 and 3x to the 4. Now 9 to the 4. Let's see. Because we want to write into some thing raised to the fifth power, and we know that 9 to the 4. 9 to the 4 is 9 times 9 times 9 times 9, right? So if you 3 times 3, 3 and 3, right? 3 and 3, and another 3 and 3. So if I go ahead and let's see how many pair of something raised to the 4 I can write. Raised to the fifth. Okay, because we need to simplify with the fifth radical here. So we have only one pair, right? Okay. So I can I can write it as fifth root of 3 to the 5th times 27, right? Because 3 times 3, 3 times 3, 3 is 27. X to the 4 times 4, we already learned this formula, x to the 16. Right? We got the formula. Remember the formula, x to the m raised to the n will be x to the m times n. Okay. And now we know the 5 is not going to 16, so we can split it up one more time. So we know that 3 to the 5th power is 3, so we're going to have 4 times 3 outside, 3x to the 4. Fifth root of 27, we cannot do anything. But x to the 6, I can write it as x to the 15 times x. And now you cancel number 3 here, so you have 4x to the 4. 5 going to x to 5 going to 15 give you x to the 3rd. So what you have left is the fifth root of 27x, right? And x to the 3rd you simplify with x to the 4, so will be x at the bottom. So you have 4 times fifth root of 27x over x. So this is your final answer. There you go. Interesting problem, right? Very interesting problem. Okay. Now on the next example, example number 6. You see, in the first 5 example, under denominator, it's just a radical. There's nothing else. But what if your denominator is something like this? 5 over 2 minus square root 3. You see, they have radical, but they have something they added to something, in this case, and they subtracted from something, in this case 2. So if you see something like this, in order to rationalize this, okay, in order to rationalize, the tactic is you need to multiply, okay, multiply the top and the bottom by the conjugate of the bottom. So the problem when we need to how are we going to find the conjugate of the bottom? Oh, the conjugate is nothing but sign changing. So the conjugate of 2 minus square root of 3, okay, conjugate of 2 minus of 3, 2 minus square root of 3 is 2 plus square root of 3. So what is the conjugate of 2 plus square root of 3? It could be 2 minus square root of 3. Okay, so that's what we have to do. So we just need to multiply. So I multiply the top and the bottom. Oops. I'm going to multiply the top and the bottom by the conjugate. Alright, so I multiply by the conjugate. So this is the bottom. I multiply by the conjugate. Okay. Now I can go and distribute it if you want to. Give you 10 plus 5 square root 3. Actually, you don't have to distribute because remember the factoring form is the best form. So I think I'm gonna keep it. But the thing is, sometimes the system doesn't take it, you know. But on the test, I think you guys should keep it because factoring form is the best form. Alright, now if you guys recognize the bottom here, you have a plus b times a minus b. So this is a difference of squares. So give you a square minus b square. And now what happened here? We have 2 squares, 2 squares 4, square root of 3 squares 3. So 4 minus 3 is 1. So what you have left is just this. There you go. See, no more radical in the denominator. Okay. So that's the definition of conjugate. You just change the sign. Example 7. Now, how about I have something like this. Let's see. How about this? I have the square root of m minus square root of 3 over square root of m plus square root of 3. Alright, so I'm going to multiply by the conjugate of this, which is I multiplied by the square root of m plus square root of 3. Right? Oh, square root of minus 3. At the bottom here, I multiply square root of m minus square root of 3. Alright, so over here, this is what happened. Like this time we don't keep the factor, but this one we have to void it. Okay, so square root of m times square root of m, square root of m squared give you m minus square root of 3m minus square root of 3m. Square root of m times square root of 3 is square root of 3m. Minus times minus will be plus. Square root of 3 times square root of 3 will be square root of 9, give you 3 over. This is the difference of squares, so it is be a square minus b square. Alright, so I'm going to combine that term. So square root of 3m minus square root of 3m will give you minus 2 square root of 3m plus 3 over square root of m squared is m. We already know that square root of 3 squared is just 3. There you go. That's your final answer. Okay. I mean, it's easy. It's not really that bad, you know. As long as you know the conjugate, you should be you should be okay. You know, if if you don't know the conjugate, then you don't know which one you multiply the top with. But the conjugate is nothing but is to change the sign. Okay, it's to change the sign. And remember this: every time the question is simplification, simplify radical expression, you must rationalize it as much as possible. Okay. Alright, so I think I'm gonna stop my video over here. It's a pretty long lecture, and let me know if you have any question. Okay, I'll see you next time.